Welcome to today's lesson. Actually, I'm going to take you through a lesson chemistry, and particularly we will look at group 7 elements in the periodic table, that is the halogens. So we go straight into the lesson. Really, I'll start by actually introducing myself. I am Siamasaka Halogens, and actually, I offer certain services. Actually, regardless of the place where I am, you can contact me through this email address, ksiamasaka@gmail.com, and the WhatsApp number is +2609774199949. Actually, if you have assignments which you are given, I know these assignments are pointers to actually examinations. I can actually sort them out. That is in chemistry and physics, and as well as questions. If you have questions which give you some headache, I can solve them, and I put you at ease, and so that you can actually times you have messed up and by missing actually some concepts, I can go through you. I also offer actually one-on-one lessons online, regardless of where you are, so we can actually tackle a number of topics that you feel important for you to actually understand. Well, as well as the examination question papers, we can solve them, and the specific topics of your interest. And at a very small token here, which is merely appreciating that you are doing something, and yet you benefit immensely. And so today now we'll go through the lesson. Actually, we are looking at the periodic table. Well, on the periodic table, we have halogens. Halogens are actually in group 7. Of the periodic table. They are located actually just here, going down there. They are actually a group. So we have fluorine with the atomic number 9, chlorine 17, bromine 35, iodine 53. So the atomic numbers we can see is actually increasing down the group. And so these group 7 elements are known as halogens, and they have actually 80 electrons in the outermost shell. For example, as we have seen here, fluorine has 9 actually atomic number. And so fluorine, if we are to look at the electron configuration, it means that we're going to have 2 and 7, meaning that for it to be stable, it requires 1 electron actually to come through it. And the chlorine, if you look at chlorine, it has actually the atomic number 17, meaning that the first shell, we're going to have 2 electrons. The second shell, we're going to have 8, and then 7, which makes it actually 17. And you note that actually all these actually the valence electrons, the electrons are 7 actually in the outermost shell, and yet for them to be stable, they require actually to gain 1 electron to make them 8. So they have all a valence of 1 because of the gaining of 1 electron to attain actual stability. They are diatomic, meaning that 2 atoms, for example, fluorine, you light it, like that. And chlorine, you write it like that. As well as the bromine, you are going to write it like that. And the iodine, you are going to write it like that. So in nature, actually, they come as diatomic, in that diatomic nature. Diatomic actually meaning they are composed of two atoms. Two, di means two. So they are composed of two atoms. However, if he, for example, actually fluorine here, it contains only the same element, but two atoms actually. It is known as homonuclear. Okay, and so we are looking at these elements actually, which are in group 7. And so the elements, as we stated earlier, we have fluorine, chlorine, bromine, iodine, and we have seen that actually these are diatomic in nature. That's the chlorine, being that will be written that manner, bromine, and iodine. Okay, and the atomic number we have seen here, this one is 17. And we wrote actually electronic configuration for 2 of these to actually show really that there are 7 electrons in the outermost shell, which are the valence electrons here. And the valence itself is 1 because all of them have to gain 1 electron to attain stability. And at room temperature here, they have a state which is actually, as shown here, fluorine is actually a gas, as well as chlorine is a gas at room temperature. Bromine is actually liquid, and iodine is a solid. And the color actually, fluorine is yellow, and yet chlorine is yellow green, and bromine is actually red brown, and the iodine is actually gray black. These are very important physical actually properties we need to know, because they are really at times asked in examinations, really to know whether you know the state in which each of these elements occur at room temperature, as well as the color here. So this is what I really wanted to state. For example, the iodine actually, if you expose it here to heat, what happens is that it will change color from actually gray, black. It will change from solid actually to form some vapor, and that's what's known as sublimation. It changes the actual direct instead of actually melting. Since it's a solid, instead of melt, it changes direct to a gas, which is known as actually from solid. Because ideally, a solid is supposed to melt, becomes a liquid, and then it goes into that state of a gas. However, for iodine, when you actually exposed to heat, it changes direction from actually a solid to a gas, meaning that it sublimes. You can test actually the presence of chlorine by actually using a damp, meaning that it should be wet, universal indicator, which actually will change color from red to, and then it will bleach it, meaning that it will lose color, it becomes white. So this is actually a test for chlorine. You expose to a damp universal indicator, and then the color will change from red to white, meaning it has bleached, it has changed actually the coloration of the universal indicator from red to actually white, meaning that it has lost its color, it has been bleached here. Reactivity of group 7 elements, which we called actually halogens. We call these elements as halogens. We actually, it decreases than the group. As we saw fluorine, we said the atomic number actually is 9, meaning that electron configuration is actually 2 and then 7. And we saw chlorine, it has actually 17, meaning that it is 2, 8, and 7. What this means is that actually for the incoming electron in fluorine, it is actually easily attracted to the positive nucleus of the protons, and therefore it is near the nucleus. So it is easily actually enters to be actually form a stable electron configuration of 2 and 8. And so because this other one for fluorine actually has, chlorine has actually 3 shells, what it means is that the incoming electron is very far and it's attracted less, and therefore you notice that the reaction here will not be as fast as it would be in fluorine. And so you notice that actually as you go down the group, the reaction actually decreases. What it means is that we expect fluorine to be more reactive than chlorine, and chlorine to be more reactive than bromine, and bromine to be more reactive than actually iodine, and so on and so on. And so the reaction that these elements actually undergo is known as displacement reaction. Really, it's a displacement reaction because only a more reactive halogen can displace a less reactive halogen. What it means is that if you have fluorine actually and reacting with the potassium chloride, what it means that this one will easily displace, because this is more reactive. It will displace, to take over the position of chlorine, and therefore what we're going to have is potassium chloride plus chlorine. Similarly, if I have chlorine reacting with potassium bromide, what it is that I'm going to, this chlorine can easily displace bromide, so we're going to have potassium chloride plus actually bromide. We said that diatomic. So meaning that actually a reaction like this one, bromide, actually reactive with potassium chloride. This reaction actually it will not take place because here bromide cannot displace actually chlorine because it's less reactive. So this is what is known as the displacement reaction. So in group 8, actually we have another group of elements which are known as noble gases. They have one electron configuration of stability. For example, here has 2 already, and the rest of these you find in the atmosphere actually have 8 electrons, and this is found in the extreme here. So these actually don't react at all because their atmosphere is already completely filled, and so they are stable. We call them stable, and therefore they don't react. If you expose them to another element, they will not react here. The non-metals here, and mainly they are gases at room temperature. They are cars, and much is not talked about them because of the actually their reactivity. However, they have very essential uses because of their reactivity and their density. For example, helium, which can easily be used in balloons, and the argon, which is used in bulbs because it does not react, even if the copper element, a copper metal, is actually there, it will not react. neon can also be used in electrical discharge tubes. So because of the reactivity, we find out that actually they are actually used widely in environments where reaction are not actually necessary. And as we indicated, that actually we have on the periodic table, we have this from here, these groups up to there, between group 2 and 3, where we have actually transition metals. Transition metals. Briefly, I'm going to talk about them just by looking at how they are reacting. And the next lesson we'll look at potentially the actual reactions. Well, these mainly they have variable biases, meaning that at times some of them they can have 1 or 2 variances depending on their reactions. They have also a high melting points when you compare it to group 1, like the alkali metals. They have also high density when you compare them to alkali metals, group 1 elements. They are less reactive with water than compared to group 1 actual metals. And so briefly, I thought we can talk about these transition metals, but broadly, we will have a lesson specifically for transition metals. And so I thought in this part of the lesson, we'll look at actually group 7 elements and how they react. And we have seen actually that the main reaction that the halogens undergo is basically the reaction of displacement. But however, as we saw earlier, they can also react in other reactions where they react with maybe group 1 elements, like chlorine, for example, can react with, as we saw actually chlorine can react with, apart from the displacement reaction, we saw here, like potassium can react with the halogen chlorine to form actually potassium chloride. Yeah. Okay, so you can balance it, put it to two. So really, so mainly here, the most important reaction is actually the displacement reaction, where one halogen which is more reactive actually displaces the other one. So I thank you.